All right, guys. So today we'll be going over the school API challenge. This is our challenge to create an API project using Django and then testing it out with Postman if we have some time. So again, the goal of this is to serve up JSON formatted data from our Django project so that we can consume it with a front end app if we were to create one. Obviously, today we're not going to create a front end application, but that's the overall goal of creating APIs so that there can be applications that consume the data if they need it. All right, so I've already cloned down the project. We'll go through our usual motions. Again, we've done this probably dozens of times, but still got to do it each and every time. So you got to create a virtual environment. We'll get that done. We need to get into that virtual environment. Then activate. All right, bunch of steps to go through. We're going to do pip install Django and probably do a psycho pg install also. That'll take a good 10 seconds maybe. But yeah, so looking over the challenge, we need to create basically two resources. One is a student resource. The second is a course resource. Also, there's probably going to be some interaction or association between them. So that's something we want to keep in mind. Hopefully you guys are kind of picturing what the models might look like, or at least what interactions they might have. All right, so our Django installation should be done now. Let's clear that out. All right, a couple extra steps. We want to create a database that we're going to use here. So I'm going to create a school DB. Create DB school DB. Do I have that database? Nope. All right, cool. So school DB is my database name. We need to create our Django project. So Django admin start project. Name our project. I'm going to name mine school_proj. Keep my name consistent and don't want nested folders. All right, cool. So we want to create an app also. So we do that by doing Python manage.py start app. You could also do, I think, Django admin start app. It does the same thing. But I'm used to using Python manage.py. So school_app. And I did not want that capitalized. Why did I do that? All right, so we have our app created. We have a database created, app created, project created. Let's get into our next few steps. I need to go to my settings file and set two values. One is the app name that I'm going to use. So I created school app. So I need to tell my project about that new app right here in the installed app section. Secondly, I am choosing to use a Postgres database. So I'm going to update the database section in my settings file to say PostgreSQL and PostgreSQL. And then the name of my database, I name my database school_db. All right, those are checked off. So my settings are updated. We got everything else going. I think we're ready to actually start our project. So just creating some notes, not really that crazy of notes, but let's say notes.py. Just as a reminder, we have four main things we need to accomplish. One is we need to create some models. Secondly, we need to create serializers, which will package up our data. Serializers. I can't spell and talk. Third, we need to create our view handlers. And then fourth, we need to create our URLs. That's for routing. That's for processing requests. This is for packaging up our data. And then models is to store represents our application data. Okay, so those are the high level things we need to accomplish. Again, I always like starting with models, but there's no rule that says you have to start with models, but I think it's usually good to do so. So let's get to our models. I'm gonna go to school app, open up models.py, and let's kind of start thinking about what our models are gonna look like. So per our requirements, we need to create a student model. So we're gonna create that first. And we're just gonna work with just the student model first. Again, kind of following directions here, release one, only students. We're not gonna worry about courses right now. So we create the student model. So student models.model. And then what sort of field do we have? Well, I assume a student's going to have a name. So I'll give them a char field, models char field. We need a max length. Hopefully they don't have long names, so it's 64 characters. What else could be in a student record? Just kind of shout it out. Any ideas what you guys want to put into our record here?
Age.
Age. Yeah, I'm gonna put date of birth just because age is kind of fluctuates. Date of birth always stays the same. So I'll say DOB is gonna be models.date field. We can probably add a validator here. Again, we don't go too crazy with validators, but date of birth should not be a date in the future. So if you wanted to, let's just sneak in a validator just this one time. From Django.core, is it? Validators, import max value validator. And we also want a date time module. Import dates, I think is the function. All right, so just again, the idea here is date of birth should not be in the future. That would not really make sense. So here, I'm going to add a validator equals max value validator. The limit value is going to be dates.today. Dates. All right, I think that should accomplish it. Hopefully my syntax is right. If not, we'll figure that out later. All right, date of birth. Anything else we want to add in here? It's a couple more fields. What do you guys think?
You can add the courses now.
Courses would be good. I'm going to hold off on that. I just want to focus just on students right now.
Grade level?
What was that? Was that grade level or reading level?
Grade level.
Grade level. All right, sure. We'll put what grade they're in. I will make that a numeric value. So it's going to be an integer, assuming they're in, grade school. So models.integer field. We can use integer choices. We did that, I think, earlier. Let's do that now. Why not? So I'm going to create a new class. Just going to add some more stuff here. I'm going to say grade choices. It's going to be models.integer choices. Again, this is just limiting our choices for what grades are going to be. So we're going to say K is going to be 1. Let's say K is going to be 0. 1 will be 1. First, I guess. That makes more sense. Second grade. It's going to get kind of tedious, isn't it? Third.
I have a question regarding this, the choices.
Okay, your audio is a bit.
If you wanted to make the choices like words, would you use the same process? Okay.
Sorry,
You
audio
guys
is a
still
bit-
can't hear me, or can you hear me now?
we can hear you. It's a bit
Okay.
laggy. I heard something, but I didn't process quite what you were saying.
I was just saying that if you wanted to make it words, how would you do it? And like strings instead of numbers.
Oh, yeah. There's you can do strings. I think there are char field choices or something. Again, I might need to look this up because I don't do it too often. But I think just choices or text choices would be the candidate here. And then again, there's probably good enough Django documentation that I'm not going to try to figure this out, but it's probably similar where you set some values like, kindergarten,
Okay.
Yeah. So again, Django has a lot of specialized fields. So text choices is probably going to be the answer to that, but we'll just keep this as, I'm just going to do 5, 6 grades. I don't want to type them all out. So choices will be grade choices dot choices. All right. I don't want to make this too complicated. So I think these are 3 good fields. If anyone thinks of any other good fields, we could add them in later. I think.
Wait, I'm sorry to interrupt, but wait, on line 17, doesn't it have to be validators instead of validator?
Probably. I was unsure about that. So we'll trust. Yeah. Validator sounds right because we have more than one. Thank you, Kat. All right. So that's our student model. Let's just go with this. Probably should add my done string method because I always forget that. Self return f string and just self dot name should be good enough. All right, so we have date of birth, grade, and the name. I don't think that should be good enough. All right, so we created our model. We just want to focus on students, so ignoring courses right now. So now I'm going to go with making migrations. Make migrations, because we have our model in place. All right, cool, no errors, that's a good sign. And now we want to migrate this to our database, but in addition to that, everything else that Django wanted to migrate is going to get pushed now when I hit migrate. So again, a lot of stuff got dumped into my database. Most of it was for Django's sake, but notice that my school app migration file also got migrated to the database. All right, cool. So we have a student's model that we created. I'm going to add a couple items to my database. I'm going to do that through the admin panel because that's the easiest way I know how. From models, import everything, admin site, register the student model. All right, and we also need to create a super user so that we can access our admin panel. So we do Python manage.py create super user. Admin will be their name, super secret password. Yes. All right. So now we should be able to run our server and get access to our admin panel. So I'm going to do that right now just to get my server up and running. Make sure I didn't mess up anything. Okay, so server looks like it's running on port 8000. So let's go to our browser, go to the admin panel, log in, and cool. So notice we could add some students now. Let's add a couple records just to check this out. So if I go to name, let's go with Bill Gates will be one of our students. Date of birth, have no idea when Bill Gates was born. Let's just guess 1953, maybe. Let's say he's in 3rd grade right now. Save that. Okay, so Bill Gates got added. Let's add Elon Musk as another student in our school. Again, don't know how old he is. I'm going to guess 1967. I don't know if I'm way off. Let's say he's enrolled in kindergarten. Okay, so we have 2 students. We'll check in on them a bit later. It looks like everything's working great. All right, so that's part 1 of 4. Part 1 was models. We can check that off for students, so that's done. Let's get to writing our serializer for our students model. All right, so I'm going to create a new file. And this is not a Djangoism, as in you do not have to create a file named serializers. You can put this in models. You create another file called whatever you want. But serializers is a good enough name, so I'm just going to stick with a nice consistent name, serializers. All right, here we're going to create, basically the goal of a serializer is to create, we're going to create a class that can convert Python, complex Python data into simplified Python data, which can be translated into JSON kind of natively. So what I mean by that is JSON can only really manage, JSON can only really deal with very basic types. So when we say basic, we mean lists, dictionaries, and then your primitive types, which are string, int, bool, I think null. I think these are the only 6 items that are covered by JSON. So if we have, if we have a Python list, then we don't need to do any conversion. JSON's good with that. But if we have a list of complex types, for example, we had a list of students. Well, yes, it is a list, but it's a list of complex data types. So we need to have a serializer that can convert students into basic data types. So usually that's going to be a dictionary representing the student object that we have within our class or within our application. So that's, again, what we're going to accomplish here with our serializer. So let's create a serializer called students serializer. This will have a couple methods. I'm going to just create one method. I'm going to call it serialize. I'm going to do things a little differently than we did yesterday, but hopefully it's not going to throw anyone off. I'm actually going to create an init method. So let's create serialize. I'm going to create an init method and treat our class a little differently. This is, again, a little different than what we did yesterday in terms of our design. And there are, I guess I kind of regret some of the design decisions we made yesterday. So I'm going to try to make it a little better today, where we pass in the students here, if it exists. Okay, so we're gonna store a student instance within our class as an instance attribute, and then we'll use it in our serialized method. So previously, yesterday, we created a serialized method where we passed in the student object to this method. We're gonna do things a little differently where the class is gonna manage the instance. There's not a big reason why this makes a difference, but it's a little more cleaner code or a little better design, but won't really chat too much about that right now. All right, so serialize we'll take our object and convert it to basic Python format, also basically akin to JSON format. So here we need to return what our student's gonna look like. So we're likely gonna have our name. We also have an ID we wanna send back. So we'll do ID equals self.student.id. And we have name, self.student.name. What else do we have? We have date of birth. We'll call it DOB, self.student.date of birth. I'm not sure if we need to convert that to a string, so we'll find out in soon enough. So DOB, then we had grade, which was self.student.grade. All right, so that's pretty much it. That's all we're doing with our serializer. We're taking a Python object and returning some more basic types. In this case, this basic type is a dictionary. JSON knows how to convert a Python dictionary into JSON format. Kat, question?
Yeah, yesterday, did you use an init method as well? I don't remember that, but I might have just missed it.
I did not. So this is something
Oh.
doing slightly differently. Previously, we passed in student to this method without having init methods. We effectively didn't really need instance methods with the way we did it yesterday. They all could have been class methods because they didn't have any internal data. Now I'm actually going to use an instance and store a student record inside of an instance of a student serializer. So it doesn't make any difference, again, what we're doing. It's just kind of a different design approach that I just want to introduce here. All right, so we don't need to pass in a student record. It's going to be part of our instance. And so we access that instance via self.student and then get all the fields that we want and return it. All right, so that's our student serializer. That's all we need. Nothing too complicated. We're not going to deal with nested serializers at this point. But okay, so that's our serializer. That's step 2 of our process. So we could check this off kind of mentally for students. Next up, we have views. So let's go to our views.py. And then we want to add some view handlers. So define, all right, so we have 5 basic operations that we normally want to do. Let's just list them as a reminder. We want to list all. We want to create. We want to detail. We want to update, and then we want to delete. These are our 5 main actions that we're worried about for the student record or their student model. So if you remember from yesterday, we talked about sort of not optimizing, but refactoring our code so that it's a little more condensed. So I'm going to go with that approach here, just to kind of keep things consistent from what we did sort of yesterday and what we're going to do later on today. So I'm going to just create 2 methods here. I'm going to create student list view handler. So that's going to be a request object coming in. And then here, I'm going to set up my usual safe code. All right, so I'm going to check for what type of request we got. So the list view can handle, it's going to handle 2 items. It's going to be the first 2 up here, because the first 2 actions do not require an instance to exist. List all just lists every piece of data that we have. Create creates a new record. Neither of these care about any particular instance existing at that point in time. So I'm going to say, if we have a request that was a get, this is going to be our list all. So let's put our HT method here. That's going to be a get request. So the get simply wants to return every record that we have in our database. Now the step that we had to add in here is we need to access our database records, convert all those records to a JSON format, and then send it out as JSON. So here we're going to do We need our model, so we need to import that. So from .models, import, let's get everything. We're also going to need our serializers. So I'm going to import that right now. Import all of our serializers. And we also need to use a Django method. So that's from Django.http import Json response. We want to send out JSON data. So we need Json response to actually do that conversion for us. So just to reiterate, we're going to pass the JSON response basic Python type. So at that point, we haven't fully converted it to JSON. We've turned it to a type that can be converted to JSON automatically. And that's what JSON response is going to do. So we import JSON response, and now we can go back to our code. So here, I want to get all my objects. We'll say all students equals students dot model objects dot all. All right, so that's all of our Python records. We need to convert them into a more manageable type. So I'm going to say serialized. Let's call them serialized students. Is going to equal a list because we have multiple students potentially. So this list is going to employ my serializer. So student serializer. We need to pass an instance to it. So again, this is a design change we've made. So I'm going to want to double back on it just to make sure we're following along. So if I do a split screen over here. So this is what our serializer looks like today. Yesterday, we had a sort of different design. We had a method called serialize all, which we could introduce here. I'm not going to do it because I don't feel like doing it. But this is all that we have access to in our serializer. So we need to pass in, we need to initialize or we need to create an instance of a student serializer object by passing in a student instance. So here, it's going to take in a student's instance. I'm going to call it S. I'm going to do a list comprehension. A little more advanced, but I'm hoping everyone is comfortable with list comprehensions. We're going to do all students. So what this is doing is we have basically a query set, which you can think of as a list. We're iterating through every individual record, calling that S. So each S is going to be a student instance. With that, we're going to create a student serializer instance and call serialize on that instance. Kind of a lot going on in one line. I'm going to pause here, and if there's any questions about what we're doing here, please ask. Jesse?
Yeah, can you reiterate again what we're passing in for the S in student serializer?
Yep, so S is going to be a student record or a student instance that we're going through our query set here. So this query set has all of our student instances, whether we have 0 or 500 students. All students are going to contain a record for each one of those students that exist in our database. Our list comprehension is basically going to say, all right, for every student, grab me that student, and then for each student that we have, create a serializer instance and call serialize on that instance. So again, we're creating an instance right here with what I've highlighted. We're passing in the student record, and we call serialize, and serialize is going to use that student instance to convert the data record for student to a kind of a basic Python type.
Okay, so basically my understanding is that for S in all students, that S is what we are calling for in the student serializer, and we serialize that.
Yep. So
Okay.
S is just a variable name. I can call this student if that makes it more clear for anyone. I can do that. But yeah, again, that's just a variable that we're going to use to create our instances of our serializer here. So serialized students will be a collection of serialized objects, and that's what we want. So let's get away from split screen. So we have serialized students. The third step here is we need to send out the message via JSON response. So I'll return a JSON response. I need to set data equal to serialized students. I need to send a status code, status AOK, which is code 200. And then the third parameter, when you are sending back a list of serialized objects, you need to set the safe parameter to false. Why do we need to do this? Again, I'm going to rely on Django documentation to tell us why, but based on examples I've seen, this is not going to work unless you set this equal to false. All right, so those are our 3 steps. We get our data records, serialize all of them here, and then we send out the JSON response here. All right, if we get an error, hopefully we don't, but if we do, that's, sometimes in life we get errors. We want to do something here, so I'm going to maybe create a method called error on request. That takes in an error string and returns a JSON response that says, I don't know, error, and whatever the error message was. Status. All right, so it's gonna be a 400 code. That means something went wrong. Anyway, so in that case, we get an error. I'm going to return error on request. Okay, so sorry, I'm having a lot of typing issues today. All right, so we get a get request. That means we want to return a list of students, but that's not the only type of request that we may get for this view handler. We also might get a post. I don't know why I split this out. We might get a post. That's a create action. So if someone sends a post request to the same URL for this view handler, that means they want to create a new student record. So let's add that case in here. We can do an elif requests method is post. We're gonna need to do something else. I'm gonna pass on that right now. Just focus on one method here. All right, let's go over to our URLs. So we haven't completed all of our views, but we completed one. I just want to test it out, make sure all the wires are connected. So here I'm going to go to my projects, urls.py. We need to add some records in there. So here I need to add a path. Our base, I'm going to call our base path school_API. Again, that's just a naming choice. You guys can name it whatever you guys choose to. I'm going to include all my app paths. So I'm going to do school_app.urls. And we need to include that function. All right, so that's our project URLs. I'm going to copy that just for convenience. I'm going to go to my app folder and create a urls.py in my app. And then that's going to look very similar to my project URLs with a few differences. We don't need the admin function. We don't need this path. But now we are going to create students as a base, and what view is going to handle that. So we need to import our view handlers, new dot views, imports everything that the views have. So we named this view handler student list view, and we can give that a name. I don't think we're going to use that name anywhere, but student list view. Let's call it student list. All right, so now if we send a get request to this path, we should be able to get a list of students. If we have screwed up something, then that's something we need to check. So, all right, so we did our 4 steps here. Obviously, we didn't do everything we needed to, but we created models. We created a student model. We created a student serializer so that we can take Python objects and convert them to basic Python types, essentially JSON. Then we have our views that will handle all the processing. So we get a request, we determine what we need to do, and the views kind of do all the steps for us. And then the URLs is kind of how we actually get to this point of which view is going to be handling it. So it's actually going in reverse, where the URLs are the first in line of determining who's going to handle the request. Views does all the processing, serializers and models are on the backside. Any questions to this point? Andrew?
Yeah, I had one. Can you go back to your serializers? Or sorry, not the serializer, the view file.
Yep.
I think Jake asked it yesterday, but I'm actually a little confused, like why we made the decision. Like, why do we create an instance of a serializer? Like, isn't it really just running a? It's really just running a function, right? So we're like creating it in the instance, then running like one of the methods like underneath it. Like, why not just run like a function? Is it like a design choice thing?
Yeah, I would say design choice thing. Yeah, we could create a standalone function where we pass it a student object and it just gives us back kind of serialized version of student. Yeah, this will be done with a function, but again, classes are kind of the better design approach. Again, we talk about OOP a lot. Student serializer will grow in scope. Again, one reason, if you guys remember from yesterday, I know you guys maybe don't want to, but when we created nested serializers, we took advantage of inheritance. Like there's no easy way to do it without inheritance there. We could duplicate our code, but inheritance solved a lot of problems for us with nested serializers. So that's, again, one benefit of creating a class for this. Again, in this simple case, yes, we could probably get away with a function. But I guess, yeah, if you guys want to create a function, it's design choice. But in this case, I'm going to go with the class if everyone's cool with that too. But yeah, good point. You're right. This is a pretty simple class that doesn't need to be a class in this case. All right, so any other questions? Yulin?
On line 32, why did you pass in a string arrow in there?
So we're returning a JSON response. So this error message has to be a primitive type or has to be a basic type. Again, one of those 6 that I mentioned. So I want to ensure that this exception, we convert it to a string manually. I mean, that might be automatically done if we try to print out, or I guess we're not printing anything out here. So I need a basic type. So I'm converting whatever exception we get. It has a under string method. It's going to give me the string representation of that error or that exception. Because an exception is a complex data type. It's just like a student's record. There's an exception record that we have. We can't send that out automatically via JSON. We need to convert it to a more basic type in Python. In this case, I chose to do a string, create a string out of it.
Okay, thank you.
Thank you for your question. All right, so my server's running. Let's give this a test. So something that I didn't do yesterday, but I did in the breakout session, thanks to Andrew, because I didn't really think to do it. But we can use our browser for GET requests. So when we navigate to a certain route, it's always, or a certain URL, it's always going to be a GET request in our browser. So I can go to localhost 8000. We want to go to /school API /students, and this will send a GET request to our view handler. So notice we got some records back because we created a couple records via our admin panel. And that's what we get back. This is the JSON data that's being sent to our browser. So our browser receives it and then just parses and displays it in its view here. Any questions about how we got to this point? Okay, let's keep going.
If you click the arrows, does it do anything on that site?
Yeah, so I have a plugin that's like,
Oh,
it makes the JSON formatted better. I forget what the plugin is called. Maybe I can find it. JSON formatter. I'm sure there's a bunch of them, but I'm using JSON formatter. It just gives you a nice presentation in your browser.
that's good to know. I thought it was a bug. I was just like, how to do that?
Sorry. Yep. Nicely add-on to our browser. All right, cool. Let's keep it going. So we have done 1 of 5 methods here. Let's do our create next. I'm gonna ask you guys, the audience, whoever wants to give their input. Do you guys want to use model form to do this, or do you guys want to do it manually and avoid using model form? Anyone have a thought?
Model forms.
Model forms? Okay. I heard Lyman, so we'll go with model forms. Again, this is just a really, really powerful tool in Django that makes our lives much easier. Especially when we get to our many-to-many relationship, the form will handle it for us. We don't need to kind of worry about the peculiarities of many-to-many. So yeah, let's use model forms. To do that, I need to import another Django function. So Django.model.forms, import model form factory. We're going to use this factory to create model form classes. So I guess we could do that in this file. Might want to organize that a little differently if I had more time. But okay, we're gonna use model form. So now we have some steps to go through. Let's actually list that out in comments. What are we doing when we get a post request? The first thing we need to do is extract the body message from our request. After that, let's number these maybe. So that's step one. After that, we need to convert our data to model data. After that, we need to, I'll do the comments as I'm doing this. All right, so we need to extract our body message from our request object. We can do this via the JSON module in Django. It makes it really simple. So we import JSON. All right, so that module will make this really easy. And then to get the data, all I need to do is call JSON.load and pass it the request object. This load function will automatically look in the request body, figure out what data is in there, and then convert that to a Python data type here. So this is going to be most likely a dictionary. I guess it could be a list, but when we're creating an object, it's going to be a dictionary containing all the fields that we need for the new student. All right, next we want to convert our data to model data. So here, this is where model form comes into play. So if I create model form up here, let's say student form, and then we're going to use this factory function. So there's a lot of magic going on here. I know it's probably still kind of curious what is actually going on here, but this factory function will spit out a class. So student forms is going to be a class that we're going to use later on. So model form factory, we pass it the model, what model it's going to represent, and also what fields we want it to manage for us. So the easiest here is to do __all to tell it, hey, every field that the student model has on it, we want this form to manage all those fields for us. All right, so this creates a new class. So student form is a class now that is a model form. So now we can create an instance of that form. Say form equals student form. Here we pass it the data. And I think that's all we need. So we pass the data that we extracted. It's going to take this dictionary and know exactly what to do with it, assuming that the dictionary has the same named fields as the model of student. So what I mean by that is whatever data we get should have key value pairs, and each key value should exactly match these fields that exist on our student record. If they don't, then we can't use model form. Again, model form isn't that magical where it just automatically knows exactly which values you want. You need to tell it specifically by the field name how to match up values from the data dictionary to our model. So that's a lot of magic going on here. After that, we can check, if form is valid. What do we do here? If it's valid, we want to save the form. So we'll do new student equals form.save. So when we save the form here, it's actually going to save the instance that it's managing. So the model form has an instance of a student that's kind of managing behind the scenes. When we do form.save, it actually saves that instance to the database, and then it gives it back to us as just as a convenience method here. So when we hit save, it's going to save it to the database, which means the new student has an ID at this point. It does not have an ID when we just give it some data, because the ID does not exist until it gets into the database. So form.save will give us the object back. We need to serialize this object and send it back to the user. That's just what they expect. So here I'm going to call, say, serialized student is going to equal students serializer, pass it our new student. And then call serialize on that. Okay, so we get our serialized student, and I have a typo there. And the last thing we want to do is return that back to we're requested that we create the student for them. So data is going to equal serialized students. Status is going to be a good 200. And step 4 is okay, so 4 steps here. Find the data from the request object, do the student form magic, which again, just going to take that data dictionary, convert it to an instance, and it's going to be managed by this form object. When we check is valid, that's going to do validations. One thing from yesterday that I said incorrectly, because I looked into it. So is valid is actually going to run validators. It does, the validators are not run automatically when you create the student form. Is valid will essentially trigger that validation when you call this method. I was not sure about that because is valid to me seems like it's just a yes or no, but this will call validators and return you a yes or no if it's valid. In the event that it's not, we need to do something. In this case, let's just return error on request and say, just do this, raise exception. Form dot errors. Okay, so some weird stuff going on here. Basically, form.errors is some weird format. We need to convert it to a JSON type, and then we're going to raise an exception, which means this exception handler is going to handle that for us if we get an error. If we get an error, we'll see if that works. If not, we'll hope that it works. All right, so let's actually see if this works now. So we cannot use our browser to do a post request easily. We can create a form. It's going to require more work. So again, I can't just use my browser to send a post request as we did, unlike we did here where we send a get request to that same route. So this is where Postman comes into play. So I'm going to actually go over to Postman and make a post request to whatever path I want to. So I'm going to go to student new, make sure all this stuff is set up correctly. This was from a previous iteration, so we need to change some stuff. So my path is going to be localhost 8000, school API, students. We don't need this /new. My body's got to match exactly what I expect on the other side. So we had date of birth, and we also had grade. I think our grade choices are only K through 5. So let's say Mickey Mouse is going to be in grade 4. Date of birth of Mickey Mouse, I honestly have no idea. Maybe 1908. I don't know when Walt Disney created this character. Let's say that was Mickey Mouse's date of birth. All right, so these are the 3 pieces of information we need to send. Obviously, we do not send an ID when we're creating this resource. That's what the server is responsible for. So we don't have any ID we're sending. The ID will be sent back to us once this item is created. So I have a post request. I have the correct URL, and I have the data sent as JSON. So make sure you have selected the JSON option here. We're not sending it as text format, not XML. We want JSON format. So that's what our server is expecting. So with this in place, there's one more thing that I just remembered before sending this. We need to set up CSRF exams. I was about to forget it, but something in my mind went off. So from Django.core import decorators views decorators import CSRF. All right, CSRF. There it is. All right, so from Django.views.decorators.csrf, kind of long path there, took a while to find. We want to import this function that's called CSRF Exams. I guess it's a decorator. So with that decorator, we can decorate our function to say, hey, we don't care about the CSRF token validation that Django normally does. So that's what we're going to tag this view with. All right, so with that in place, hopefully things will go smoothly. So I go back to my Postman. I'm going to send this request and we'll receive a response from the server down here. Hopefully it's a 200, status 200 response. And we see the actual record that got created. But if we get an error, we'll have to figure out what's going wrong. I'm going to hit send here. All right, I'm actually surprised. I was expecting an error, but there we go. Notice we got the same data we got back, but the new piece of information here is the ID of the new record that got created in our database. Our server spit it back out at us. And now we know that Mickey Mouse is student number 3, or student with ID number 3. So if I go back to list all, let's just do it in our browser. Yep, there we go. Mickey Mouse was added to our school database. Okay, what questions do you guys have here? Andrew Tran.
I have one on your, could you go back to your code, the save functionality?
Sure.
I think it was like the first time I've seen it, but you like put a variable equal to the save thing. So the save is doing like 2 separate things in this case, right? It's returning the value of like the object that we saved, and it also saves it to the database at the same time.
Yep.
Okay, yeah, I just wanted to make sure. I don't think we've seen that before.
Gotcha. Yep. Again, model form has a lot to it. So I know, we haven't gone over model form too much, but high level, it does a lot of processing. We tell it what dictionary to work with. It will create an instance for us and do the rest for it. It's super simple. Again, this is much easier than what we did yesterday, kind of initially where we did it all manually. Right, so that is the create method. I think we're running kind of low on time, so I'm not going to get to the update, delete, and the detail for the student, just because, again, those are not too much more difficult. Again, the create and update are very similar. So again, the logic here will be very similar. The only difference is here, you're going to need to pass it an instance keyword argument, and this instance will be your existing record that you're updating. So that's for the update case. For the create case, we have no instance, so this is set to none automatically. Okay, and then for the delete case, you guys can figure out delete. It's probably the easiest of the operations. The get detail, again, very similar to get all, but instead of doing a list of serialization, we just need to find one record, serialize it, and send it back. All right. If there are any questions on those, we can talk about it, but I want to get to courses. So let's get back to our process. So we did student. Let's do the same thing for courses. So I'm going to do class course models model. I'm going to do it kind of quickly. So we're going to have a name. That'd be models dot char field max length 64. Description is probably something that a class has. Models dot char field max length 255. All right, that's all I'm going to add for my course model. I'm not going to go too crazy with it. All right, so we have course. Great. But now we have a relationship question to ask. We have 2 models. We want to determine how they are related, if at all. Sometimes models are totally independent. So we want to ask, well, what's the relationship between students and courses? So again, we've done this before, so I'm just going to kind of go over it really quickly. A student can be in 1 or more courses. So a student can be in many courses if they want to. There's nothing that our school is going to limit them in terms of enrolling in classes. But one single course can have multiple students enrolled in that same course, right? It's not a private tutoring company. So in this case, we have a many-to-many relationship with these models. So we can create a many-to-many field in one of these models. We can pick either one. It's reflexive, but in this case, since my student model is defined first, I'm going to do it in my course model. And here I'm going to say students is going to be models dot many-to-many field students. So we're saying that we have a many-to-many relationship with this model and the student model. However, if you remember from our examples before, we also have a concept of enrollments, and that enrollments is a join table. I see some hands raised, so let's see what the questions are. Jesse?
One question I had is kind of dealing with what was talked about yesterday and dealing with the courses, because I was putting in with credits and I was working with putting credits with courses, and I was trying to see if we can do like a function like what like we did yesterday of adding all of them, all the courses to that student, and I was just trying to figure out how that would work on the serializer, and I was trying to work with what you were doing yesterday. I think I was going the wrong approach.
Sure. Credits make sense. Models, integer fields. Okay, good suggestion there. Let's actually take this piece by piece. So I'm gonna hold off on the many-to-many relationship if you guys are fine with that. So let's just trying to think. Yeah, let's do that a bit later. This is getting to be a long challenge, but I think it's worthwhile. So let's take a break here. I'm going to add some code over the breaks just to kind of get this going. But we have our course model. I'm going to make migrations. I'm going to migrate it. I'm going to create some similar views that we did before. And then after break, we can kind of talk about new additions that we're going to add to that. So it is 10:03. Let's take a 12-minute break. And if any questions pop up over break, definitely ask them afterwards. But I'm going to kind of get this process going just so we don't take as much time going through the nitty-gritty of stuff that we've done before.
Hey, Ankur, do you mind showing the top of views.py just for like a couple of seconds?
Sure, I'll leave it up over the break. But
Thank you.
all right, let's get back together at 10:15 and continue on from there. Okay, so while you guys were away, I did a few additions, nothing too crazy. I created my model, I migrated it, did migrations. I created my serializer for courses, very straightforward, very similar to my student serializer, taking a course instance, return ID, name, description, credits as a dictionary, nothing crazy going on there. The point I'm at now is I'm updating my views. So again, I'm going to write something that's very similar to my student list view for courses. So it's going to be so similar, in fact, that I'm going to want to pre-refactor this, or prefactor this, I guess is the term I use. So I created a new file called views helpers, and I'm going to take what I had initially for my students and make that as generic as I can, meaning any other resource could use this method. And it's kind of semi-convenient that I'm in this new file. I'm getting these yellow squiggles because I've not imported everything I need to. And this is going to cue me into what is not generic about this right now. So I have student serializer, student form, and student serializer again. These are the things that are specific to the student resource. Everything else that's being done here can be done for any other resource because it's not specific to students. So given that, I need to figure out how to pass these appropriate classes to my list view that's going to be generic for all resources. So here, I'm going to add some more parameters. One is going to be model type. Second is going to be serializer type. And the third looks like I need to pass it a form. So I'm going to pass it form type. All right, so keep in mind, these are going to be variables that refer to class names. This is totally legit in Python. It's actually really cool that you can do this in Python. So these will refer to classes, and we're going to use those classes inside of our generic method here. So instead of referring to students, now we're going to refer to something called model type, which may refer to student, but it could refer to any other model class that I pass in here. Same thing with serializer type. That could be any serializer that I pass in here. It's not always going to be the student serializer. It could be any serializer that we want. So I'm going to substitute that in. Last thing is form type. We're not going to use the student form all the time. We're going to use any form that we tell this method to use. All right, so with those 4 changes, this method is generic. Obviously, there's some naming things that I want to do here. So maybe find, sorry. All right, I want to find word students, replace that with item, I guess. That's a generic name. All right, item, singular, do that. All right, replace students, plural, and then student singular with item. Hopefully, all right, I'm gonna trust that did everything we wanted to. So now this is super generic. It refers to items, not students, and takes in any model type, serializer type, and form type that we specify. So with this refactored code in place, I'm gonna go back to my views file, gonna import from views helpers, import everything you got. And now, again, this is what I had for my students method before. All this is going to use that refactored method that I just created. So I'm going to delete this good chunk of code, and I'm simply going to return the list view, pass in the request objects, but I need to pass in some other items now. So if I save this, all right, so my view helpers are over here. I have 4 items I need to pass. The first is the request object. Second is what model do we want to use for a student list view? Well, that's going to be a student model. What serializer do we want to use? So that's going to be the student serializer. And what form do you want to use? That's the student form that we are creating with this model form factory. And so that's all what my student list view is going to look like. But now that I've done this, my course list view is super, super simple to create. I can just do course list view, pass in course here, course serializer, and course form, which I need to create still. So course form is going to be very simple. So this is where we're leveraging the power of Django. A lot of these are just built-in things that make things much quicker. So course goes here. That's our course form. And then we're good to go. My course list view should be up and running. I added some seed data during the break. So if I save this, I do need to add URLs. That's the thing I forgot to do over break. So I go to my URLs, not my projects. Here, I'm going to add a route to the courses list view. It's going to have appropriate naming, course, and of course, course. All right. So with that in place, looks like I have a typo in my imports with a dot here. All right, so now I'm importing my view helpers, which has the generic methods. I forgot a comma, shame on me. Okay, now we should be good. Yes, we're good. All right, so if I go back to my browser, and now we navigate to courses, that is course singular. Man, I just have one typo free day. All right, sorry, I had bad naming here. So let's try that again. There we are. I've created 6 different courses. We have biology 101, calculus 104, etc. that I've created. So our list view is working just great. All right, that was, again, that took like what, 2 minutes after a refactor to get everything wired in. So again, that's the advantage of doing that. If we had 5 more resources, super simple to create a list view. But in addition to doing list views, so in addition to just listing all and creating new objects, which we can do, if you want to see that quickly, let's go to our Postman. Let's create a new course. So we're going to send a post request to courses. And we want to send it a name. Name will be history 211, description would be, I don't know, stuff happened. And then we need a credits, number of credits that this course counts for, not 9, that's a lot of credits. I think 4 is a good round number. All right, so we send a post request to this location. We should create a new course. Let's see if this happens. If I forgot something, then we'll see. Oh, all right, so I did forget something. Where? I think the return value right here. So we got an error somehow, and I'm not sure why we got that error. I guess we'll find out. So let's try that again. Credits, this field is required. We got a typo, right? Good error reporting, so I need credits, plural. My bad. Here we go. So we created a 7th course with ID 7, history 211, stuff happened, got it. So this works, no surprise there. Let's get to the update, delete, and detail portion for courses. I'm going to do this in a generic manner, so I can do this for students really easily also. So I can go to my view helpers. I'm going to write a very generic function, but hopefully you guys can follow along. Whenever I refer to model type, that's going to be either student or courses. Same thing with serializer and form type. So here we're going to create another view that's going to be generic. Call it detail view. It's going to take in a request. It's going to take in a model type, which again could be a student object or student class, could be a course class. We're going to take in a serializer type and form type. All right, this is going to get a few different request types. So I'm going to copy this piece of code. Put it here. Let's grab these goodies over here. All right, so we have a few more cases we want to handle. So we did list all and create with the other handler. In this case, we want to do a get request, which is going to be a detail view, just return the object. We're going to do a put request, which is going to be update the given object. Or we're going to do a delete request that's going to delete the given object. So with that in mind, I'm going to add these in here. So get request, we have a put request for updating. And then we have another request, elif requests method for deletes. All right, and we'll pass on implementing that right now. Okay, so let's see how these will need to change. This is going to be a detail view. I guess we need a fifth item here. We need an item ID. So given that an item ID will be sent to us for the detail view, we should be able to query our query set and do ID equals item ID. Again, this will refer to either student or courses or whatever resource we are getting a detail for. We're going to specify that by the top level view handlers. But here, we want to get one item. We want to serialize that item. So we don't need a list of it. We just need to serialize one item by calling the serializer type that we passed in. Create a serialized item and pass that back to our requester. All right, so that's our get detail view. This put request is going to be where we're updating whatever resource that has been specified by the item ID. So in this case, we are also going to need to do this get, where we need to search through our records and find the exact item. So I'm going to pull this out of my if statement because we need to do it for our else if also. Right? We don't want to duplicate ourselves in each one of these branches. If we're going to do the same thing in every branch, pull that out of our if statement. So here we're going to find the item, and then we're going to load the data that got passed for the update. In this case, for that model form, the only difference here is we do have an instance that exists right now because we need to update a given instance. We set it equal to none when we're creating something because we had nothing to go off of when it doesn't exist ahead of time. Here, we pass this a value of item. So the item that we're updating, we need to pass that to model form and say, hey, the current instance that we have right now on our hands is item. You're going to take in data and update the item based on whatever is in the data dictionary. That's what model form is going to do for us. So we pass it the item, we pass it the data that we want to be updated with. We do the same thing, is form valid. In this case, it's not going to be a new item, it's going to be just the item. So appropriately name that. So that's all we had to do. Not too much different. We could combine the logic here and up here because they're very, very similar. I'm not going to go through that because that's going to make the code a little more complicated. I don't think we have the time for that. So, but that's our put request. We extract the data, tell model form what the data is, and then proceed to save the updated record. The last case, which is super simple, we have our item. We found it up here. We just want to delete it. So I'm going to do item.deletes. That's a Django query function. And then I'm going to return something to the user saying, hey, we deleted whatever you told us to delete. So I'm going to say data is going to equal some dictionary saying status. And that will be a 200 error code. So status is going to be 200. Just call this a message. I saw a hand raised. Please ask your question.
So I don't know if it's just nitpicking, but on line 40, would you do a get instead of an all since we're doing delete and we don't want to maybe possibly delete a bunch depending on the input we get?
Oh, that is not nitpicky. That is an accident on my part. That should be get. Sorry. Thank you for pointing that out. So yeah, we want to do a get, not an all. My bad there. So get, we specify exactly what we want to get. Thank you, John Winko. Cool. All right, I think that's all we need for our generic method. I might have mistyped something. That's quite possible, but let's actually get this hooked up. So now we have that generic method. For our course view, we're going to call course detail. This should be passed a course ID. That'll come from our URLs. We'll see that in a second. But now that we have a specific course ID, we pass that down to our generic method. And that generic method will handle the rest for us. So the detail view that we just coded up, we tell it exactly which model, which serializer, which form to use. It's going to do the rest. And this is so generic that I could just do a copy paste. And it should just work for students if we rename everything to students. Student detail view, students ID, students, student stuff here. All right, so let's test this out quickly. Don't want to spend too much time on it, but we want to test out the detail view. We need to create new routes to get to this detail view. So that's where we go to urls.py and say, hey, how do we actually get to that detail view? Well, for courses, we're going to go to course and a specific course ID. That's how we specify what we're actually investigating or updating or deleting. So this is going to be course ID. Excuse me. This is going to be our detail view. We'll call this route detail. And we'll also do this for our students. Sorry, I got something stuck in my throat, I think. Students, student ID. All right, give me one moment. I'm gonna get a sip of water. Sorry about that. All right, sorry for that water break. All right, so we have our routes coded up for the detail view. Going to student / whatever ID. Let's test these out. So I'm going to save my file here, not forget my commas this time. All right, so is my terminal happy with my changes? Yep, looks like that's good. Let's test it on our browser. So we test a detail view in our browser.
Line 7 should have course change to student.
Thank you. Name also. Thanks for having extra eyes on my code, guys. All right, so let's go to course detail. So I'm going to go to course number, let's go to course number 3. That should be ART 200. All right, there we go. That's the detail view. So this is, again, a GET request that we sent to the URL for details. Now, we can't set a put, we cannot send a put or a delete request through our browser very easily. So that's where Postman comes back into the fray. So we go over to Postman. And let's do a update. So if we go to course update, make sure we're going to do a put request, not a post. We're doing put. So I'm going to select put. I'm going to drop down. I want to send it to localhost 8000 courses /3. That's the detail view. I think our course was ART 200. I want to keep that the same. Let's change the description. So the description was draw stuff again. Let's make that draw fancy stuff. All right, that's where we're going to update the description. Number of credits will still remain. So we'll do credits will be, I think that was a 4-credit class. Yep, 4 credits. So we're only changing the description. But even though we want to change just the description, for a put request, we need to send all the fields back to the server. We can't just say, I'm only sending you a description. There is another method for that. We'll get to that probably in a lecture. But in this case, even though I want to change one field, still need to send all of them and make sure that I haven't changed anything else. All right, so with this in place, I'm going to cross my fingers. If I send a put request to the detail URL, that should update this to be draw fancy stuff. So let's try that. We got an error. That's fine. It happens. So let's read the error message. Bad routing. So school API courses. Courses, the slash at the end? I don't think that's it. Let's take it out. Okay, I guess it was a slash at the end. I need to figure out when we need slashes and we don't. But anyway, this works. We got a description that got updated. So the update worked. Again, the ending slash, sometimes Django will complain about it. Other times it won't. I haven't figured it out even to this point, but okay. So that works. Let's test out our deletes. So if I want to delete something, Jake, you have a question, comment?
Yeah, I just wanted to say on your URLs, you didn't include a slash at the end just now. And I'm wondering if you put slashes in there now and you go back and do the same thing with the slashes, will that work?
You're right. I meant to put slashes there. Kind of going too quickly here. Yeah, if I do it now, I bet it's not going to work. Let's test it out. Yep. Good catch. I do want those slashes there. Okay. So we updated. Let's do a delete. So I'm going to go to my other method. It's going to be a delete request. Send it to the right URL, /3, not students. We want courses. All right, so we send a delete request. Again, nothing goes in the body, right? For a delete request, we're not sending any information aside from, hey, we want to delete this item. So if I send a delete request, let's see what happens. Yep, we got our message back saying successful delete operation. Thumbs up, that works. I could do this for students and it's going to work. Let's do just one quick update for a student. Mickey Mouse was student number 3 in our system. Let's do an update, Mickey Mouse. What did I do for the detail? All right, Mickey Mouse, this was the original record. We go for an update. Let's say Mickey Mouse has made it to grade 5 now. And let's say he was actually born in 1919 on 1/19. All right, so I'm going to upgrade Mickey Mouse's grade and date of birth. Let's see if this works. Send a put request, not a post. So if I send a post, I'm going to get an error. So I've not handled that method. This should be a put because that's what we specified on the other side. So I send that. And there we go. Mickey Mouse got updated. And that is working pretty well. So it didn't take too long. Once we had one resource, again, it's pretty easy to get the other resources up and going. So that is student and courses. The last bit we need to do, and this is a really long challenge, but I think it's worthwhile, is we need to do the many-to-many relationship between our models. So I kind of held off on that before. We've talked about it before, student and courses. Sorry, before I get to that, was there any questions about anything we did before? Okay, so we're going to implement the many-to-many relationship. So I kind of started that before, but I held off on it. I'm going to introduce that back. So we have many-to-many relationship with students. We need a related name here. So that's going to be courses. Again, remember, this is how the reverse side of this relationship will refer to this data. So that's, in effect, creating an imaginary field here called courses. Now, this is something that we need to think about. Django is automatically going to create a join table for us if we do not choose to create one for ourselves. As in, if we don't create a join model. But in this case, I think we do want to create a join model for this representation because let's take a look at what that's going to look like. It's going to be enrollments, and we can call this whatever we want, but enrollments is a good word for it. Model.models. And again, this is just going to be a join table. Nothing too fancy in here. We're going to do foreign key to a student record. Models.foreign key. Students on deletes. Models.deletes. Cascade. Related name, always good to have. How do we refer to this relationship? On the other side, we're going to call this enrollments. All right, we're going to pair a student ID with a course ID, and that's what this table in effect keeps track of. It pairs students and courses together. in a many-to-many fashion. So we have course, course, course. All right, cool. But the reason I chose to create an enrollments table is because we want extra data with this partnership of a student in course. So one student is enrolled in one course. There's extra data that we could keep track of. In our examples from times before, we had the idea of a student earns a grade in a particular course they're enrolled in. So we need to create this new model because we need to keep track of extra data. If we only relied on the many field, we wouldn't have the option to create the extra data anywhere because Django would just create a join table with two values in it, foreign key to student and foreign key to courses. So this is what the default join table will look like on the backside. But now that we want to add a new data member here, we got to do this new model. So I'm going to do chart field max length, I think 2 characters, so A+, A-, B-, whatever. We could add in more here, but I think that's good enough. So I saw a hand raise. If you want to ask your question, please do so.
Yeah, so I did something similar to that, where you have the 3 different tables. But what I did, instead of having students on course, I just would have it like backtrack through enrollments to get the students for the courses, if that makes sense. And I was just wondering, like, would this be better practice to have the students directly attached to the course rather than going through the enrollments table to get the students?
Good question. I think I understand the question. Let me answer that in a second. Course.name. All right. So Marcus's question or comment was when he created a similar setup for his homework. He's correct me if I'm wrong, Marcus. You said you simply relied on this foreign key and did not create this many-to-many field. Is that correct?
Yes.
Yes. That will. Let's see. That will work, but that kind of handicaps us in terms of accessing the records directly. So without this many-to-many field, this will work because we have the join table. This is what we did when we had just writing raw SQL tables. We created a join table, had 2 foreign keys pointing outward. That's all we did. So you're right. We don't need to create this many-to-many field, but this many-to-many field is a convenience for us as developers. It gives us access directly from courses to students without having to go through this table manually. But if we did not have it, it worked just fine. It's just a little more work to kind of find the records we're looking for. So yeah, good comment there, Marcos. But in this case, I do want to create it because it's just nice to have it. But the difference with what we did before is that now that we have a manual join model, we need to specify in this many-to-many field, there's a through value, and that's going to point to enrollments. Without this, Django would say, all right, I'm going to create the join table for you because you didn't tell me otherwise. But now we've told it otherwise that Django, we have our own model that's going to act as a join. So you do not need to create your own table, just base it off this model. Okay, with that in place, we need to do our migrations. So this is definitely going kind of long, but hopefully you guys are enjoying it. So let's go with make migrations, migrate, and run server. Cool. Was there a hand raised there? Jesse.
Yeah, so this is the part where I was trying to figure out on whether I wanted to serialize or having a new method within the models about aggregating for a sum like you did with the other piece yesterday.
Mm-hmm.
And if we wanted to do something like that, if I say I wanted to get all the credits for that student, for instance, and get all the number for that student.
Sure. Yeah, absolutely. We can do that, and we will do that. Thank you for that suggestion. Let's get our enrollment serializer going here. So we had 3 fields. It's going to be student, ID, or ID student, and course. And what was it? Grade, I think. All right. So we had grade, we had course, and we had student. Right, these need to be renamed to enrollments. All right, so this is where we introduce sort of the idea of, well, we have nested relationships. How do we deal with them? We are not going to deal with nested serializers for this challenge. That's going to add a lot more than we care about. So again, this student is a Python object. It's an actual reference to a student model. It's not an ID at this point. In Python, in Django, this is actually a full reference to an existing student record. We cannot just return that right here because that is a complex data type. So we need to handle this and convert it to a basic data type. Again, it needs to be a dictionary, list, a string, integer, something that JSON is happy with. So that's what our decision here is. The typical case, the simplest case is we just return an ID. I'm going to do .id for course also. So now we're just going to return an ID for the student, an ID for the course, and then whoever's consuming that data, if they care to know more details about that particular student or particular course based on the enrollment information we gave them, they will have to make another API call based on that student ID that they have in hand. The alternative.
Oh, sorry.
Go for it.
I'm just wondering, do you need to allow for a course to be made without any students, like a null student?
Are you asking in this setup,
Like,
can student be null and course be something?
Yeah, like in the model, do you need to allow for that?
By default, all these fields are non-null. So if I try to put a null value in, it will most likely complain. It's kind of backwards of SQL. In SQL, you got to say not null explicitly. In Django, that's a default, because I think that's the typical case for most fields.
Okay.
We could test it out though with Postman. So we'll try to send a blank field and see what happens. All right, so this is our serializer for enrollments. Let's get the party continued in our views. Again, we've done this before. We have generic code. So it's so generic, I can copy, paste, rename quickly. So course becomes enrollments. And then, no. Selected text only, please. All right. All right, so enrollment, and then we have lowercase, I think a couple of these. Enrollment ID. All right, so I think that's all we had to do. Enrollment should be good to go. We need to do the routes for them, but that's just copy, paste also. As you can see, development, it's really quicker since we smartly coded it up before. And this is kind of a good prelude into Django Rust framework, which is going to be our lecture topic. This is essentially what Django Rust framework is meant to do. Since we're doing these things repeatedly and it's so generic, Django Rust framework has already created methods for us that can handle essentially what we're doing manually here by creating generic methods. That's what Django Rust framework is. It's a generic kind of layer where we can extract a lot of complexity onto that library. So enrollment detail, did not rename them. I did not. All right, is that all I need to do? Cool. All right, so we don't have any enrollments right now. Let's do that quickly in our need to register that model. Did I make migrations? Anyone remember? Forget if I did. I think I did. Okay, cool. All right, so if I go back to my admin panel, refresh. Hey, look, there's enrollments here now. So let's add a couple enrollments. Student Bill Gates is taking Donuts 202. It's great. He's not doing so well in Donuts 202. He's got a C-. All right, let's add a couple more. Elon Musk is also in Donuts 202. And guess what? He's even worse at it. He's got an F currently. They need to up their donut game. Say Mickey Mouse is in History 211. Mickey Mouse is a good student. Gets a B+. Let's say one more enrollment. So let's say Elon Musk is also in History 211. Let's say he's really good at it. He's got an A+. Okay, so we have our enrollments. Let's do our GET request through our browser. So I'm going to go to /enrollments. Forget my S's all the time. There we go. These are our enrollments. Gets working. Nothing too surprising here. The one thing I did want to point out here, again, this is how the data is being serialized and sent over to the browser. Again, these are only IDs. I do not know the name of the student based on the data I've sent back. So this is one drawback of this design compared to nested serializers. This data would tell me the student name, also what additional courses the student's in, and also potentially what grades they have in those courses. So that's where nested serializers do a lot of the work for us and it sends us a lot more informational data instead of just sending us kind of flat data values, in this case, an ID where we need to do an additional lookup for additional data. I'm not going to bore you with Postman, but I'll let you know it's going to work with Postman. I guess we did have one request of doing it with a null value, so I'll do that one. That's all you get out of me for Postman. So enrollments /3. So let's update this enrollment where student has a B+. I think that was Mickey Mouse. Let's say he failed the test, so he gets a lower grade. So we need to adjust that. So let me copy this. We need to send a put request to enrollments, the third enrollment. We need to add a body here. So this is going to be for enrollments. Enrollments. And this is an update. Okay, so we need to add a body. So I go to the body section, click on raw, select JSON, paste in the body, and we're going to adjust Mickey Mouse's grade to be, let's say change to a B- now. Let's say it's a C+, whatever. So we set up put requests. That's important. Make sure our URL is correct. This should be enrollments, not courses. Enrollments. And then the suggestion was, what if we pass a null value here? Will this work? Let's find out. Let's say we're changing student to null. I'm going to send this request. Got an error. Keyword, course ID. My serializer screwed up here. Nope, that's right. Let's read the error message. Detail view got an unexpected keyword, course ID. All right, probably didn't rename it. Oh, I know what I didn't do. Didn't rename these. Yes. Copy and pasting has its drawbacks in that I'm making many typos, but okay. So that should be enrollment. This should be enrollment. And that should be enrollment. Okay, so we should get enrollment ID. Let's try that again. Send that puppy. Server's dead. It's a lie. Okay, so it looks like that is required. We can't send null value by default. So this is Mickey Mouse. Send that over. Cool. So Mickey's grade is now a C+. This works. That's a school API. That was a lot that we covered, but hopefully that was kind of informational and beneficial. I know we have run kind of long with this challenge review, but before we wrap up, what questions you guys have about any of the stages we did? Again, 4-part process for all of these resources. We go through models, serializers, views, and URLs, and kind of keep going over and over for each resource that we need to add. What questions, comments, thoughts, concerns do you guys have out there? Jesse?
Yeah, so let's say we wanted to aggregate the credits.
Oh, right. Thank you for reminding me. Sorry, I totally forgot about that. Let's do that one additional thing. It's not too hard. So this is where we'll do it in our models. We'll say, let's add a method. Let's say that method is going to be get total credits. Now, obviously, students have no notions of credits here, but we do have access to this field in a couple different ways. So this is going to be an instance method. So there's 2 ways we can go about this. We can search through enrollments, find every student that we have and aggregate that, or we can go through the course model because we have access to courses via that many-to-many field. not sure why this is yelling at me, but okay. So in here, we want to get all the student courses. So we'll do student courses, or we already have access to that. It's student courses dot all. We want to iterate through that. So we're going to do for course in student courses dot all, which should be self dot. Sorry, I'm getting lost in the sauce here. We have a student record self dot courses dot all. We're going to go through each course and just sum up all the credits they have. So let's say total credits equals 0. Go through this total credits plus equals course dot credits. So notice that we do not have to go through the enrollment table at all. We don't care about any information. We don't care about their grade. We care about credits, which is on the course model. So we can hop directly from students to course information via this many-to-many relationship, which gives us this magical self.courses field, kind of imaginary field that got added here. So we do this, we return total credits. Keep in mind, this function has not changed my model structure. So I do not, again, I do not need to run migrations and migrate this change because my database is not going to change at all. We're not storing anything extra in a database. We just have a helper method here. So given this method, we can now broadcast that in our serializer. So here, we want to say for our students, not our course, our student, we want to see the total number of credits that they're taking. We can name this whatever we want. Student credits, self.students.get total credits, I think is what we named it. So the only things that need to change here are the models and serializers. The views don't care about any of this because it's abstracted away from them. Get total credits. All right, assuming I don't make any typos, let's see if that works. Let's go to our student lists. Made a typo, surprise, surprise. I need credits, plural. Let's try that again. All right, there we go. So notice that total credits seems to be accurate. We can go through and verify it, but I'm assuming that Elon Musk is in 2 courses, Mickey Mouse and Bill Gates are in 1 course each, with 3 and 4 credits respectively. Other way around. Okay, cool. That was, again, serializers, you can send as much data as you want or as little data as you want. You don't have to send everything. Sometimes you might want to hide the specific ID from the user. That's possible. Maybe the grade that they're in is sensitive information. You don't have to send all the data you have. It's your choice as the API developer. All right, that was a long challenge. I agree. Any other questions before we wrap up here? Okay, so the good thing is we don't have that much material to go over today because DRF is pretty simple to use. It does a lot of the heavy lifting for us. So we should be able to get through the material without issue, knock on wood. I don't have wood table here, but let's take a 13-minute break. Let me stop this.